Hello everyone, and it's your boy Habib back again once again. I know it's been 2 months since my last integral video. Well, what can I say? I've just started my undergraduate journey and it's been a bit hectic. But no worries, I'll definitely be dropping some of those weird looking integrals in the coming of months. Thanks for sticking around, and without further delay, let's kick off June with a fresh integral right here, right now. So the integral what we have here today is which is I equals to 0 to 1 sine square ln x over ln square x dx. Well, first of all, we shall write this using the Feynman technique, which is I of alpha is equals to 0 to 1 sine square alpha times ln x over ln square x dx, where in this case when I of 0 is pretty much 0 and I of 1 is just literally our integral which we want to find out the answer. So we get I prime of alpha equals to integral from 0 to 1 to sine alpha ln x times cosine alpha ln x over times ln x over ln square x. So we can clearly see that this alpha ln x and one of it will cancel each other out, and what we have here is final answer 0 to 1 sine 2 times alpha ln x over ln x and dx. Well, I think we can actually differentiate both sides once again. So we get I double prime of alpha is equals to 0 to 1 cosine 2 alpha ln x times 2 times ln x dx over ln x. Well, pretty much these things will cancel each other out, and final we have 2 times 0 to 1 cosine 2 alpha ln x dx. Okay, so how the hell I'm going to solve this from here? Well, we know that the Euler form e to the ix is just cosine x plus I times sine x, right? So what we can do here is let's I think okay, by plugging x equals to 2 alpha ln x, we get the cosine form and the sine form together, right? So by simplifying this part, we get x to the power 2 alpha times I, which is equals to these parts. So what we need here is that I double prime of alpha is indeed 2 times 0 to 1, the real part of x to the power 2 alpha I dx. Okay, cool. So 2 times, and we can literally integrate this, so we can just write x to the power 2 alpha I plus 1 over 2 alpha I plus 1 from the boundaries 0 to 1. Let's move on to page number 2 where we are. Okay, so this becomes 2 times 1 over 2 alpha I plus 1. So well, I can actually rearrange this, so we can see that the complex part is in the denominator, so why shall we not multiply it by its conjugate? Terribly sorry about that. 2 alpha I minus 1. So 2 times 2 alpha I minus 1 over minus 4 alpha square minus 1. Well, indeed, we can range this once again, and we get I double prime of alpha is indeed equals to 2 times 4 alpha square plus 1 and minus 4 alpha, which is the imaginary part, for alpha square plus 1. Okay, cool. So what we need is the real part. This is the real part we need to integrate. So the I double prime of alpha, which is equals to 2 times 4 alpha square plus 1. And so what shall we do next? Again, now we need to integrate both sides with respect to alpha. In that case, we get I prime of alpha is equals to, this is just the tan inverse of 2 alpha plus the any constant. And we also know that I prime of 0 is pretty much 0. You can clearly see that the upwards, where is that, we got that. Here, I prime of 0 is pretty much 0, because in the sign 0 gives us the 0 part, so we don't need to worry about that anymore. So we can clearly see that its constant is actually 0. So what we have is the final form, which is I prime of alpha, which is equals to tan inverse 2 alpha. So what's next? Again, integrate both sides with respect to alpha. So in that case, we have I of alpha, which is equals to, and if you do some partial integrations here, we get the final form alpha times tan inverse of 2 alpha minus 1 over 4 natural log of 4 alpha square plus 1, and don't forget the c once again. And we know that the alpha of 0 is also 0. So in that case, now c becomes 0, 2. So our final if alpha, which is alpha times tan inverse of 2 alpha minus 1 over 4 natural log of 4 alpha square plus 1. Indeed. And just we need to plug the alpha equals to 1 to get the answer. So if1 is the integral what we need to find the answer. So which is tan inverse of 1, sorry, tan inverse of 2. Terribly sorry about that. Where is that? Okay. So tan inverse of 2 minus 1 over 4 natural log of 5, which is an approximate answer 0.70 blah blah blah. I don't need that. So here we go, folks. This is a final answer format. Where is that? Let's take this one. Okay guys, here we go. This is a final answer for our required integral today. Alright folks, that's a wrap for today's integral. Hope you had fun solving it with me. More mind-bending ones are on the way. Don't forget to like, share and subscribe if you haven't already. Until next time, stay sharp, stay curious and keep integrating. It's your boy Hubby signing off with peace.